September 21st, 1944, dawned gray and ominous over the rolling hills of Lorraine, France, as Hauptmann Klaus Müller crouched behind the twisted remains of a Panzer IV, watching through his field glasses as another American Sherman tank erupted in flames. The sight should have brought him satisfaction, but instead, a growing unease gnawed at his experienced tanker's mind. Something was different about these new American machines, something that defied everything the Wehrmacht had learned about the notorious Ronson tanks that supposedly lit up like cigarettes at the first penetrating hit. Müller had been fighting American armor since the Sicily campaign of 1943, and he had witnessed firsthand how the early Sherman tanks would catastrophically explode when their ammunition stores ignited, sending turrets flying through the air like grotesque firework haze. The German tank crews had grown confident, almost contemptuous of the American steel coffins that seemed to burst into flames at the slightest provocation. They had nicknamed them Tommy Cookers, after the British portable stoves, a grim joke that reflected their apparent vulnerability to ammunition fires. But today was different. Müller had watched his veteran gunner, Unteroffizier Hans Steiner, score 3 direct hits on Sherman tanks throughout the morning engagement, and while the American crews had bailed out as expected, not a single tank had experienced the violent ammunition explosion that had become their signature death throes. Instead, the Shermans had simply caught fire in a more controlled manner, their crews escaping with remarkable frequency compared to the wholesale slaughter Müller remembered from earlier encounters. According to declassified U.S. Army Ordnance Department records from the National Archives, the Americans had been secretly implementing a revolutionary safety system called wet-stowage in their Sherman tank production lines since early 1944. This innovation involved storing the tank's main gun ammunition in specially designed racks surrounded by water and ethylene glycol coolant, creating a protective barrier that would prevent the catastrophic ammunition explosions that had plagued earlier Sherman variants. The German intelligence apparatus, despite its legendary efficiency in other areas, had completely failed to identify this crucial modification to American armor. Wehrmacht tank recognition manuals continued to eschewed standard Sherman silhouettes with no indication of the internal changes that were transforming the battlefield dynamics. German tank crews like Müller's continued to expect the dramatic secondary explosions that had made Sherman hunting such a profitable enterprise in previous campaigns. As Müller lowered his binoculars and prepared to relocate his concealed Panther tank to a new firing position, he couldn't shake the feeling that the Americans had somehow changed the rules of engagement without bothering to inform their opponents. The tactical implications were staggering. If Sherman tanks were no longer the vulnerable prey they had once been, the entire German defensive strategy would need fundamental revision. The morning mist began to lift from the battlefield, revealing the smoking hulks of both German and American armor scattered across the pastoral French countryside. Müller's experienced eye counted the casualties. 3 Shermans disabled but not destroyed, 2 German Panzer IVs completely knocked out, and 1 Panther immobilized by track damage. The mathematics of attrition were shifting in America's favor, and Müller was beginning to suspect that German tankers were about to face their most challenging opponent yet. Not just American numbers and industrial capacity, but American engineering innovation that their intelligence services had failed to detect. March 15, 1944, had marked a turning point in American tank production when the Detroit Tank Arsenal implemented the most significant safety modification in Sherman history, though the workers on the assembly line had no idea they were creating a weapon that would fundamentally alter armored warfare dynamics. The wet-stowage system represented years of painstaking analysis of battlefield reports, survivor testimonials, and metallurgical research conducted by the U.S. Army Ordnance Department under the direction of Colonel Harold Thompson, a former automotive engineer who had witnessed too many American tank crews perish in preventable ammunition fires. The technical specifications of the wet-stowage system were deceptively simple, yet revolutionary in their implementation. Each 75mm main gun round was stored in specially fabricated steel containers surrounded by a water glycol mixture that would absorb the heat from pen, attracting projectiles and prevent the propellant charges from reaching their ignition temperature. The system required precise engineering to maintain the protective fluid levels while allowing for the rapid loading sequences that Sherman crews needed to maintain their rate of fire advantage over German opponents. Thompson's team had conducted extensive testing at Aberdeen Proving Ground throughout late 1943, subjecting prototype wet-stowage Shermans to deliberate penetration by captured Sherman anti-tank rounds. The results exceeded their most optimistic projections. Ammunition fires that had previously occurred in over 60% of penetrating hits were reduced to less than 10% with the new system. The data was so impressive that General Leslie McNair personally ordered the immediate conversion of all new Sherman production to the wet-stowage configuration. The manufacturing challenge was enormous, requiring retooling of multiple production facilities across the American industrial heartland while maintaining the accelerated production schedules demanded by the European theater of operations. Ford's Willow Run facility, Fisher Body Division, IN Grand Blanc, Michigan, and the Lima Locomotive Works all received priority allocation of materials and engineering resources to implement the wet-stowage modifications without disrupting the flow of replacement tanks to combat units. Security surrounding the wet-stowage program was surprisingly lax by modern intelligence standards, though this proved advantageous in maintaining operational secrecy. The modifications were classified as routine production improvements rather than revolutionary tactical advantages, and technical specifications were distributed through normal industrial channels without the special handling procedures that might have attracted German attention. Factory workers understood they were building safer tanks, but few comprehended the strategic implications of their work. German intelligence collection efforts during this period focused primarily on American tank production quantities rather than qualitative improvements, a strategic oversight that would prove costly on European battlefields. The Abwehr's Technical Intelligence Section received scattered reports modifications to Sherman internal layouts, but these were dismissed as minor engineering adjustments rather than fundamental capability enhancements. German tank recognition training continued to emphasize the Sherman's vulnerability to ammunition fires, creating a dangerous overconfidence among Wehrmacht armor crews. By June 1944, when the first wet-stowage Shermans rolled off the landing ships at Normandy beaches, American tank crews were largely unaware they were operating dramatically safer machines. The tactical doctrine remained unchanged. Crews were still trained to evacuate immediately upon penetration, and Sherman employment continued to emphasize e-mobility and numerical superiority over survivability. The wet-stowage system represented a hidden advantage that would only become apparent through battlefield experience. The engineering triumph of wet-stowage reflected broader American industrial capabilities that German planners had consistently underestimated throughout the war, demonstrating how democratic societies could channel civilian technological expertise into military applications with remarkable speed and efficiency when properly motivated and resourced. August 7, 1944, brought Sergeant First Class Michael O'Sullivan his third Sherman tank in 6 weeks of fighting across the Norman hedgerows, and he expected this one to meet the same fiery end as his previous machines when German anti-tank fire inevitably found its mark. O'Sullivan had enlisted in the 3rd Armored Division straight from the Steel Mills of Pittsburgh, carrying with him the pragmatic fatalism of industrial workers who understood that dangerous jobs required accepting calculated risks while taking every possible precaution. The morning reconnaissance mission through the village of Mortain seemed routine until O'Sullivan's gunner, Corporal James Rodriguez from San Antonio, Texas, spotted the distinctive angular silhouette of a German Jagdpanzer 4th tank destroyer positioned behind a stone farmhouse approximately 800 yards to their front. The engagement that followed would demonstrate the tactical implications of wet stowage in ways that American tank designers had hoped for, but never guaranteed. Rodriguez fired first, his 75mm armor-piercing round striking the Jagdpanzer's superstructure but failing to penetrate the sloped frontal armor. The German response came within seconds. A high-velocity anti-tank round that punched through the Sherman's frontal slope and ricocheted through the fighting compartment, creating the shower of sparks and metal fragments that had spelled doom for so many previous American tank crews. O'Sullivan instinctively began the evacuation procedures drilled into every Sherman commander, preparing to abandon his tank before the expected ammunition explosion transformed it into a steel crematorium. But the secondary explosion never came. Instead of the catastrophic detonation that should have followed within moments, O'Sullivan heard only the crackling of electrical fires and the hiss of hydraulic fluid escaping from damaged systems. The wet stowage system had performed exactly as designed, preventing the ammunition fire that would have killed his entire crew. The tactical advantage became immediately apparent as O'Sullivan's crew remained in their tank and continued engaging Teehee German position. Rodriguez adjusted his aim point and fired again, this time penetrating the Jagdpanzer's side armor and setting it ablaze. The German crew abandoned their position, leaving behind a knocked-out tank destroyer and a very confused American tank crew who couldn't understand why they were still alive. This engagement represented thousands of similar encounters across the European theater, where Sherman crews discovered their unexpected survivability advantage. As reported in the 3rd Armored Division's after-action reports housed in the National Archives, Sherman loss rates from ammunition fires dropped dramatically during the summer of 1944, though few commanders initially connected this improvement to the wet stowage modifications that had been implemented without fanfare or explanation. The psychological impact on American tank crews was profound and immediate. Soldiers who had operated under the assumption that any penetrating hit meant certain death gradually developed confidence in their equipment that translated into more aggressive tactics and improved battlefield performance. Sherman crews began staying with their tanks longer after taking hits, allowing them to continue fighting instead of immediately abandoning their positions. German tank crews, meanwhile, continued operating under the assumption that successful hits on Sherman tanks would produce the dramatic secondary explosions they had come to expect. Wehrmacht tactical doctrine emphasized achieving quick kills on American armor to conserve limited German ammunition, but the new Sherman survivability was forcing longer engagements that favored American numerical superiority and more reliable mechanical systems. O'Sullivan's crew would survive 4 more penetrating hits during their advance through France, each time expecting death, but finding instead that their tank remained functional enough to continue fighting or at least allow safe evacuation of the crew. October 3, 1944, found Oberst Heinrich Kessler of the German Army's Foreign Armies West Intelligence Section struggling to reconcile the increasingly contradictory battlefield reports flowing into his headquarters from armored units across the Western Front. Kessler, a former tank officer himself who had transferred to intelligence work after losing his left arm in the Russian campaigns, possessed the technical knowledge necessary to evaluate combat effectiveness reports. But the data emerging from recent engagements defied everything the Wehrmacht thought it knew about American Sherman tank vulnerability. The statistical analysis was undeniable and deeply troubling for German defensive planning. Panzer and anti-tank units were reporting significantly higher ammunition expenditure rates when engaging Sherman tanks, with many commanders noting that American crews were remaining with the foe air vehicles much longer after sustaining what should have been catastrophic hits. The expected secondary explosions that had characterized Sherman, kills throughout 1943 and early 1944, were becoming increasingly rare, forcing German gunners to fire multiple rounds to achieve definitive kills. Kessler had requested technical intelligence assessments from the German Army's weapons testing facilities at Kummersdorf, but their evaluation was limited by the lack of captured examples of the newer Sherry, Man variants. The few American tanks that had been recovered intact for technical analysis showed no obvious external modifications that would explain their improved survivability, and German engineers were reluctant to conclude that American manufacturing had achieved significant internal improvements without physical evidence. The intelligence failure represented a broader weakness in German technical reconnaissance capabilities that had developed throughout the war as Allied air superiority, limited battlefield recovery operations, and prisoner interrogations. Wehrmacht intelligence services had become increasingly dependent on visual identification and external assessment of enemy equipment, missing crucial internal modifications that could dramatically alter tactical effectiveness. Major Wilhelm Brenner, Kessler's technical liaison officer, had compiled reports from 17 different armored engagements where German crews claimed successful hits on Sherman tanks that failed to produce the expected ammunition explosions. The pattern was consistent across Mühl-Typel fronts and involved various German anti-tank weapons, from 88mm guns to Panzerfaust handheld rockets, suggesting that the Americans had implemented some form of systematic protection against ammunition fires. According to captured German intelligence documents later analyzed by Allied intelligence services, the Wehrmacht's Foreign Armies West Section did eventually identify wet stowage as a probable explanation for improved Sherman survivability, but this analysis was completed in late 1944, nearly a year after the system's battlefield introduction. The Intel Agents assessment reached operational commanders too late to influence German anti-tank tactics or weapons development programs. The information gap created a dangerous overconfidence among German tank crews who continued to expect easy kills when engaging Sherman tanks, leading to tactical errors that cost experienced Purs en Nel and irreplaceable equipment. German commanders allocated anti-tank resources based on outdated effectiveness assessments, contributing to the Wehrmacht's inability to halt American armored advances during the autumn offensives of 1944. Kessler's final report on American tank developments, submitted to Army Group B headquarters on November 15, 1944, concluded that the U.S. Army had achieved significant improvements in tank crew survivability through unknown technical modifications. But recommended continued engagement of Sherman tanks using established tactics pending further intelligence collection. The recommendation reflected the German Army's institutional inability to adapt quickly to American technological innovations during the final phase of the European War. November 21, 1944, brought Private First Class Tony Kowalski from Detroit, Michigan, his first real taste of armored combat when his Sherman tank, nicknamed Motor City Maid N, rolled into the Hurtgen Forest as part of the 9th Armored Division's advance toward the German border. Kowalski served as loader for the tank's 75mm main gun, a position that placed him in direct contact with the ammunition storage system that would either save his life or end it in the coming weeks of brutal forest fighting. The 20-year-old former assembly line worker had joined the Army with romantic notions of tank warfare gleaned from Hollywood movies and recruiting posters. But the reality of operating inside a Sherman tank during combat bore little resemblance to his expectations. The confined SPA-CE, deafening noise, and constant fear of anti-tank mines created a psychological stress that tested even the most determined soldiers, while the legendary vulnerability of Sherman tanks to ammunition fires added an element of fatalistic acceptance that pervaded American armor crews. Kowalski's tank commander, Staff Sergeant Robert Irish McCarthy from Boston, Massachusetts, had survived the Sick Ely and Normandy campaigns in 2 previous Sherman tanks, both of which had been destroyed by German anti-tank fire. McCarthy's experience with Sherman vulnerability made him exceptionally cautious about ammunition handling and crew evacuation procedures. But he was unaware that his new tank incorporated safety systems that dramatically improved their chances of survival. The first German anti-tank round hit Motor City Maiden on November 23rd during a probe toward the village of Kleinhau, penetrating the frontal armor and creating the familiar shower of sparks and metal fragments that experienced Sherman crews recognized as the prelude to catastrophic ammunition explosion. McCarthy immediately ordered crew evacuation, but Kowalski found himself trapped in the loader's position by damaged equipment and debris from the penetrating shot. As Kowalski struggled to escape what he expected to become his steel coffin, he waited for the ammunition explosion that would end his young life in a fraction of a second. But the explosion never came. The wet stowage system absorbed the heat from the penetrating projectile and prevented the ammunition from reaching its ignition temperature, allowing Kowalski to eventually free himself and evacuate the damaged but intact tank. The psychological impact of surviving what should have been a fatal hit profoundly affected Kowalski's approach to subsequent combat operations. Like thousands of other American tank crewmen who experienced similar close calls during the autumn and winter campaigns of 1944, Kowalski developed a confidence in his equipment that translated into more aggressive tactical behavior and improved combat effectiveness. According to unit histories preserved in the U.S. Army's Combat Studies Institute archives, American tank crews reported significantly improved morale and reduced stress-related casualties during the period when wet-stowage Shermans were introduced to frontline units, though military medical personnel at the time attributed these improvements to increased combat experience rather than equipment modifications. Kowalski's crew would experience 2 additional penetrating hits during their advance through Germany, each time expecting death, but finding instead that their wet stowage system prevented the ammunitio N fires that had killed so many of their predecessors. The cumulative effect of these survival experiences created a veteran crew that could engage German armor with confidence while maintaining the tactical aggressiveness that American doctrine demanded. The loader's perspective on wet stowage was particularly significant because ammunition handling personnel bore the greatest risk from internal explosions, yet few American tank crewmen understood the technical details of the safety systems that were protecting their lives on a daily basis throughout the final campaigns of the European War. December 12, 1944 found Hauptmann Ernst Dietrich commanding a company of Panzer IV tanks in the forests near Bastogne, Belgium, preparing for what would become known as the Battle of the Bulge, while struggling to understand why his experienced crews were expending twice as much ammunition per Sherman kill compared to their earlier combat performance in Normandy and eastern France. Dietrich, a veteran of the Russian front who had transferred west to participate in Germany's final offensive operation, brought with him assumptions about American tank vulnerability that no longer matched battlefield reality. The German tactical doctrine for engaging Sherman tanks had been developed during the North African and Italian campaigns, when American armor suffered catastrophic ammunition explosions with predictable regularity. Wehrmacht training emphasized achieving single-shot kills on Sherman tanks by targeting ammunition storage areas, a technique that conserved German ammunition while maximizing psychological impact on American crews. The doctrine assumed that successful penetration of Sherman armor would produce secondary explosions approximately 60% of the time. Dietrich's gunners reported increasing frustration with Sherman engagements that required multiple hits to achieve definitive kills, forcing his company to remain exposed to return fire for extended periods while finishing off American tanks that should have exploded immediately. The tactical implications were significant because German armor units could no longer rely on quick, decisive engagements that allowed them to change positions before American artillery could respond to their muzzle flashes. Unteroffizier Franz Weber, Dietrich's most experienced tank commander, had personally engaged 11 Sherman tanks since returning to the Western Front in October 1944, achieving successful penetrations on 9 occasions, but witnessing ammunition explosions in only 2 instances. Weber's combat reports noted that American crews were remaining with their tanks longer after taking hits, often continuing to fire back effectively instead of immediately abandoning their positions as they had done in previous campaigns. The German ammunition shortage made these extended engagements particularly problematic for Wehrmacht armor units operating with limited logistical support during the Ardennes offensive. Panzer crews who had expected to achieve multiple kills with their basic ammunition load found themselves requesting resupply more frequently, creating additional strain on German supply lines that were already stretched beyond capacity by the ambitious scope of the winter offensive. German tank gunnery training had not adapted to address the improved survivability of wet-stowage Sherman tanks, leaving Wehrmacht crews with outdated targeting priorities that reduced their combat effectiveness. Training manuals continued to emphasize ammunition storage areas as primary target points, but these techniques were no longer producing the expected results against American armor equipped with wet-stowage systems. Dietrich attempted to develop modified engagement tactics based on his unit's battlefield experience, recommending that panzer crews target Sherman tanks' engine compartments and track systems to achieve mobility kills rather than pursuing the catastrophic ammunition explosions that had previously been standard procedure. His tactical modifications showed promise, but were never formally adopted by higher headquarters or distributed to other German armor units. The adaptation challenge reflected broader problems within German military training and doctrine development systems that had become increasingly rigid and unresponsive to battlefield innovations during the Final phase of the war. Wehrmacht training establishments continued producing tank crews with outdated knowledge about American armor capabilities, contributing to the growing effectiveness gap between German and American armored forces. As reported in post-war interrogations of German armor officers conducted by Allied intelligence services, many Wehrmacht tank commanders recognized that American Sherman tanks had become significantly more survivable during 1944, but lacked the technical intelligence or institutional support necessary to develop effective countermeasures against wet-stowage protection systems. January 18, 1945, marked a turning point in American armor doctrine when General Omar Bradley received detailed statistical analysis from the First Army's After-Action Review section showing that Sherman tank crew survival rates had improved by over 40% since the introduction of wet-stowage systems, though Bradley himself remained unaware of the specific technical modifications responsible for this dramatic improvement in battlefield survivability. The data represented thousands of combat engagements across multiple fronts where American tank crews had survived what should have been fatal ammunition explosions. The strategic implications of improved Sherman survivability extended far beyond simple casualty statistics, influencing American tactical doctrine, training programs, and industrial production priorities in ways that military planners were only beginning to understand. Experienced tank crews represented irreplaceable assets that required months of specialized training to develop, making crew survival a force multiplier that enhanced American armored capabilities across all theaters of operation. Bradley's staff analysis revealed that American armored divisions were maintaining higher operational readiness rates, partly because experienced crews were surviving to fight in multiple engagements instead of being killed in their first serious combat encounter. The retention of veteran personnel created a positive feedback loop where experienced crews developed sophisticated tactical knowledge that improved survival rates even further, while also providing on-the-job training for replacement personnel. Colonel James Morrison, Bradley's armor liaison officer, had compiled data showing that American tank units were engaging German armor more aggressively since the introduction of wet-stowage systems. Few commanders connected this behavioral change to specific equipment modifications. American crews were staying in position longer during firefights, taking calculated risks that previous generations of Sherman crews would have considered suicidal. The industrial implications were equally significant for American war production planning. Reduced Sherman loss rates meant that existing production capacity could support more aggressive operational plans without requiring proportional increases in replacement vehicle manufacturing. The War Production Board's statistical analysis indicated that improved Sherman survivability was equivalent to a 20% increase in effective tank production capacity. German strategic planning continued to assume Sherman vulnerability levels that no longer reflected battlefield reality, leading to resource allocation decisions that failed to counter actual American capabilities. Wehrmacht anti-tank units received equipment and ammunition based on outdated effectiveness assessments, while German training programs continued preparing personnel to engage American armor using tactics that were no longer optimal. According to declassified strategic bombing survey documents, American intelligence services eventually recognized that wet stowage represented a significant tactical advantage that German forces had failed to identify or counter effectively. The intelligence assessment concluded that German technical reconnaissance capabilities had deteriorated significantly during 1944, contributing to their inability to adapt to American technological innovations. The broader lesson emerging from the wet stowage experience demonstrated how relatively simple engineering solutions could produce strategic advantages when implemented systematically across large military forces. The modification required no exotic materials or revolutionary manufacturing techniques, yet created battlefield effects that influenced the entire course of American armored operations during the final phase of the European War. American military historians would later identify wet stowage as one of several technological innovations that contributed to Allied victory in Europe, though its significance was often overshadowed by more dramatic developments like radar, proximity fuses, and electronic warfare systems that received greater publicity and historical attention. May 8, 1945, brought the end of fighting in Europe as German forces surrendered unconditionally, but the true significance of the wet stowage system would only become apparent through post-war analysis conducted by Allied intelligence services and military historians seeking to understand how American industrial innovation had contributed to victory over the Wehrmacht's supposedly superior armor technology. The statistical evidence was overwhelming. Sherman tanks equipped with wet stowage systems had fundamentally altered the dynamics of armored warfare in ways that German forces never fully understood or countered. The final accounting of Sherman tank losses revealed that wet stowage had prevented thousands of ammunition fires that would have killed entire tank crews under the previous storage system design. American casualty statistics showed dramatic improvements in tank crew survival rates during the period when wet stowage systems were introduced, though military medical personnel at the time attributed these improvements to increased combat experience and improved tactical doctrine rather than specific equipment modifications. Lieutenant Colonel Harold Thompson, the engineer who had directed wet stowage development for the Army Ordnance Department, conducted extensive post-war interviews with German tank crews and commanders to understand how effectively Wehrmacht forces had identified and adapted to the Shermans' improved survivability. The results confirmed that German intelligence had completely failed to recognize wet stowage as a systematic modification to American armor, treating isolated reports of improved Sherman survivability as anomalous rather than indicative of broader technological advancement. The German failure to identify wet stowage represented a broader intelligence and adaptation failure that had characterized Wehrmacht performance during the final phase of the war. German technical reconnaissance capabilities had deteriorated under pressure from Allied air supremacy and accelerated operational tempo, leaving Wehrmacht forces unable to conduct the detailed analysis necessary to understand American technological innovations. Former Hauptmann Klaus Müller, interviewed by American intelligence officers during the post-war prisoner debriefing process, admitted that German tank crews had maintained their tactical assumptions about Sherman vulnerability throughout the entire war, despite mounting evidence that American armor had become significantly more survivable. The institutional inability to recognize and adapt to enemy innovations had contributed to German tactical failures across multiple fronts. The wet stowage system influenced post-war American tank design and military doctrine in ways that extended far beyond simple ammunition storage considerations. The success of the modification demonstrated how systematic attention to crew survival could enhance overall combat effectiveness, leading to design philosophies that prioritized survivability alongside firepower and protection in subsequent American armored vehicle development programs. Soviet military analysts, who gained access to both American and German tank technology through post-war intelligence collection efforts, identified wet stowage as one of several American innovations that had provided tactical advantages during the European campaign. Soviet tank design programs incorporated similar ammunition protection systems in their post-war development efforts, though they never achieved the same level of effectiveness as American wet stowage technology. The broader lesson of wet stowage extended beyond military applications to demonstrate how democratic societies could rapidly translate civilian industrial expertise into military advantages when properly organized and motivated. The modification required cooperation between military engineers, civilian manufacturers, and frontline combat units operating under extreme pressure, yet produced results that influenced the outcome of the largest military conflict in human history. As military historians continued analyzing the European campaign decades after its conclusion, wet stowage emerged as a perfect example of how incremental technological improvements could produce strategic effects when implemented systematically across large military forces, proving that victory often resulted from thousands of small innovations rather than a few dramatic technological breakthroughs that captured popular imagination and historical attention.